Welcome to section 12 for notes. This is on angle measures and segment lengths. So a secant is a line that intersects a circle at 2 points. It does not have to pass through the center. This would be a diameter. And a diameter is part of a secant. And you might be thinking, what's the difference between a chord and a secant? So again, the difference is that a chord is a line segment that has both endpoints on the circle. So that would be a chord. But a secant, the difference is instead of being a line segment with both endpoints on the circle, it is a line. And remember, a line keeps going forever and ever in both directions. And so a secant is a line that goes through a circle at 2 points. Okay, so that is the big difference. All right, so in section 12, or theorem 1213, it says the measure of an angle formed by two lines that intersect inside a circle is half the sum of the measures of the intercepted arcs. So if you see here, if we want to know what angle 1 is, okay, if this point is not the center of the circle, it's not a central angle. So we cannot say that that angle is equal to what the arc is. Okay, it's also not an inscribed angle where the vertex is on the circle, so we can't say it's half the arc. So that's where we'd have to use this formula. So with this formula, if it's formed by the secants that form an X in the circle, then the angles formed, where angle 1 or this angle, since their vertical angles are the same, either of those angles is equal to 1/2 of these two arcs added up. Okay, it's basically an average of those two arcs gives you one of those angles. You know, if I found one of these angles, I could subtract 180 to get this angle and this angle. But that's just a formula to remember based on this picture. All right. Next, it says the measure of an angle formed by two lines that intersect outside a circle is half the difference of the measures of the intercepted arcs. So in this particular case, you can see it in different ways, but you can see that these lines intersect outside the circle. So if we look at this, it says angle 1. So this little angle out here is equal to 1/2 of this arc X, which goes from here to here, minus Y, which goes from here to here. Okay, so instead of averaging them and adding them up, you're subtracting the two arcs, kind of the biggest one, the furthest one away, minus the smallest one that's closer to the angle we're dealing with. And so you got to remember to subtract. And they all look a little different because sometimes it's like a secant and a secant, and sometimes, like in this case in the middle, it's a tangent and a secant, and sometimes it's two tangents, but all of those work the same way. And it's basically, you know, in the last one we saw, it was formed by a big X and the angle was inside the circle. Now we have the angle outside the circle, and that's where we're needing to subtract to get that smaller angle. So again, this angle 1 is equal to 1/2 of this arc minus this arc. And in this last example, again, angle 1 is equal to 1/2 of this arc minus this arc. Okay, so those are the two we're kind of practicing over right now. So for example 1, we can see, and it doesn't really matter if they're chords or secants where the lines extend out to the circle. Again, it's the idea, is it formed by an X and the angle's inside the circle, or is the angle we're dealing with outside the circle? So in this case, I see an X, when I say X, I'm meaning this. These two lines are forming an X. And the angle we're looking for is right here inside the circle. So we need to take an average of these two arcs, this one and this one. So we know that X is equal to 1/2 of 46 plus 90. And if we work that out, we get half of 136, which gives us 68 degrees. Okay. On number 2, we can see in this case, move it up a little bit. We can see in this case that the angle we're dealing with is outside the circle. So that's how we know we're subtracting. They actually already set this one up for us. But if they hadn't, we would know that, okay, this angle is outside the circle, so that's where the 20 comes from. And it's equal to 1/2 of the arc furthest away minus the arc closest. And so now we have to solve this. To solve it, you can either distribute the 1/2 or you can multiply both sides by 2. Okay, either way it's going to work. I think I chose to multiply both sides by 2 to get rid of the fraction, but if you want to distribute the 1/2, that's fine. So I did 40 is equal to, I know 2 times 1/2 gives me 1, so that fraction goes away. And so I'm left with 95 minus z. And then I went ahead and subtracted 95 from both sides. So once I did that, I got negative 55 is equal to negative z. And then I just divided by negative 1 on both sides. And that gave me z is equal to 55. All right. Then if you look over here, just some more examples of those same formulas. You can see the angle we're looking for is outside the circle. So I'm going to set this up as y is equal to 1/2 of the arc furthest away, 110, minus the arc closest, which is 30. Some are easier to solve than others. It just depends on what your variable is. In this case, I can go ahead and subtract the 110 minus 30 to get 80. And then I know that half of 80 is 40. There we go. We can see number 4. These two chords are forming an X inside the circle. And so this is the angle I'm dealing with. And so, but again, when you think of these formulas, plug in what you know and solve for the thing you don't know. In this case, I know the angle, and I know that that's equal to 1/2 of these two arcs added up. So I got 1/2 of X plus 30. Okay, so make sure you're getting it set up correctly. And now last time I multiplied both sides by 2. This time I'm going to show you if you prefer to distribute the 1/2. That's fine. Either way is going to work. So in this case, I get 35 is equal to 1/2 X plus 15. You just have to make sure you distribute it to both terms. From there, I can go and subtract 15 from both sides. And that gives me 20 is equal to 1/2 X. And from here, if I try to get X by itself, I can basically multiply by the reciprocal here. Multiply by 2 on both sides or multiply by 2 over 1, either way. And that's going to give me X is equal to 40 degrees. There we go. Got 40 for both of those. All right, last 2 here. So, actually last 1. On this one, there's multiple things going on in this picture. So I went ahead and solved for X first. If you look at this, again, here is an angle outside the arc, this 48. So I know that it's equal to 1/2 of the arc furthest away, 140, minus the arc closest, which is X. All right, so from there, again, you can either distribute the 1/2 or you can multiply both sides by 2. I'm going to go back to multiplying both sides by 2. I like to just get rid of the fraction at the beginning. So I end up with 96 is equal to 2 times 1/2 is 1. So now I don't have to distribute that 1. I just get 140 minus X. From there, I can go and subtract 140 on both sides. So that gives me negative 44 is equal to negative X. So I end up with X equals 44 degrees. All right, but now I need to figure out what Y is. So I found out what X is. Sometimes it helps just to put that in the picture, and then you can use that to help you find the next thing. So If you think about how many degrees are all the way around the circle, hopefully you're thinking 360. And if you look here, I can see that 140 basically goes from here to here. Okay. And I can see that from here to here is the 44 that I just found. So now I need to figure out how many degrees it is basically from here to here. Okay, that's not going to give me y yet, but that's getting closer. So if I go ahead and add up the 140 and the 144, no, 140 plus 44, that gives me 184. And if I go 360 minus 184, I get 176. So I know that this arc is 176, and I know that y is like an inscribed angle, which is going to be half of the arc that it intercepts with. So I know that y is 176 divided by 2, which is 88 degrees. All right, so that is it for section 12.4. Have a great day, and let me know if you have any questions.